Hello everybody, this is Mr. Coker. I'm sheltering here in place in rural Gibson City, and I've got your explanations for the first 10 practice problems. Today's lesson is about conversion factor practice, and these are the conversion factor problems that we use throughout the year, and this is just kind of a review, a chance to keep your skills sharp while we're not able to meet. So across the top here I have all the conversion factors you're going to need for the problems 1 through 10 that are on the PDF that you found for these problems. I've got my answers across the side of the screen here, and I'm going to show you how to work each one and talk you through it. Remember, if this doesn't work for you, feel free to contact me or Mr. Davis and let us know by email what you need to help you keep up your learning in chemistry. So first problem, it says to convert 23.4 meters to centimeters. So up here we see that 1 meter is 100 centimeters. So what we're going to do here, we should always do this first, is write down what was given, and that was 23.4 meters. Draw your multiplication sign, draw your line, and then ask yourself, okay, now what are we going to put on top and on bottom? Well, on top we're going to put the unit we're trying to convert to. We're trying to convert to centimeters. So I'm going to take the 100 centimeters, put those on top, and we're trying to get meters canceled out. So I'm going to put the 1 meter on bottom. See up here it says 1 meter equals 100 centimeters. 1 meter equals 100 centimeters. So that's my conversion factor. Put my equal sign. Now remember, this is not cross multiply or anything like that. This is take this number times the top and divide by the bottom. Now before we do that, I want to show you that the unit meter cancels just like it was an X or a Y in algebra class. That's why we call it the factor label method. The labels are like factors in math, like X's and Y's in math that you can cancel out. So now 23.4 times 100 is 2,340. Put it in your calculator if you need to. And the unit, now that we've canceled out meters, is going to be centimeters. So this technique works on any problem where you're trying to convert one unit to another and you have a conversion factor available for doing that problem. So let's move on to number 2. Number 2, we're trying to convert 56.7 kilometers. Make sure you write it down, 56.7 kilometers, not just the number, but also the unit. The unit's going to help you because you're going to be able to figure out what goes on top and bottom. If you have your unit showing, it's going to help you. Multiplied by, up here I see that 1 kilometer equals 1,000 meters. So this time the 1,000 meters goes on top because I'm trying to change to meters. 1 kilometer goes on bottom. That's our conversion factor. So now the kilometers cancel. 56.7 kilometers times 1,000 meters over 1 kilometer gives me 56,700 kilometers. Okay, problem 3. 48.1 liters changed to milliliters. 48.1 liters. We're changing to milliliters. So we look up here, we see that 1 liter equals 1,000 milliliters. 1,000 milliliters over 1 liter. Always pick the unit I want to get to on top and the unit I want to get rid of on bottom. I want to get rid of liters because I want to change to milliliters. 48.1 times 1,000, 48,100 liters. Now at this point you might make the wrong assumption that the big number always goes on top. Well, number 4 is going to show you that's not always true. It's not the big number that we're looking for. We're looking for the number that goes with the unit we're trying to get. So number 4, we're trying to change 345 milliliters to liters. So 345 milliliters. We're going to change to liters. So we're going to use that same conversion factor, but we're going to flip it. We're going to put 1 liter on top because now we're trying to change 2 liters. And we're going to put 1,000 milliliters on bottom. We're going to cancel the milliliters. Instead of multiplying 345 times 1,000, this time we're going to take 345 times 1 and divide by 1,000. And we're going to get 0.345 liters. Okay, number 5. Make sure I get this where the camera so you can all see it. I'll try to keep it toward the middle of the camera because I think YouTube might do a little bit of chopping off the edges. So just in case you haven't been able to see some of the answers so far, I'm moving them to the middle of the screen here. Okay, number 5. We're trying to change 59 moles of water. Now we're getting away from metric conversion, but we're still doing conversion problems. We're doing moles to grams. We're trying to change 59 moles of water to grams. So we start by writing 59.0 mole water. I want to change that to grams, so I'm going to put grams on top. I'm going to put moles on bottom. So up here, we see that molar mass in grams equals 1 mole. So the number in front of moles is 1. And for the molar mass, I need to add up water's molar mass. Now water, H2O, has 2 H's and 1 O. If I look at the periodic table, remember we're rounding off to the nearest tenth. H is 1.0, so 2 times 1.0 will be 2.0. And then the O is 16.0, so 2.0 plus 16.0, 18.0 grams. The moles cancel. 59 times 18, and we get 1,060 grams. All right, now moving on to number 6. Okay, number 6. We're changing 14.5 moles of Na2SO4 to formula units. So 14.5 mole, and this is Na2SO4. Wouldn't really matter on this problem what the chemical is because the relationship is that 6.02 times 10 to the 23rd formula units equals 1 mole. So we're going to put 6.02 times 10 to the 23rd formula units and 1 mole on bottom. Moles cancel. And we get an answer of, get this where you can see it, we get an answer of, let's see here, 8.75 times 10 to the 24th. I know my writing's not very good, I'm trying to write sideways here. And our unit is formula units. All right, 8.75, get this toward the middle of the screen, times 10 to the 24th formula units. Okay, I'm going to erase everything. Hopefully you've got all the work down for the first 6 problems. I'm going to erase, and we're going to do the next 4 problems, which will finish this up for today. Now, while I'm doing this, let me remind you that since this is YouTube, you do have the option of watching it at 1.5 or double speed, assuming you can listen twice as fast as I can talk and explain. And another option is that you can fast forward to wherever you need to go. Let's say you only need to see number 6. Well, fast forward the YouTube video, look at number 6, get the explanation, and if you understand it, now you're ready to just close down the YouTube video because you got what you needed out of it. Okay, now we're ready for number 7. So number 7 is 6.79 times 10 to the 24th molecules of H2SO4. Notice I didn't use the term formula units, and that's because H, S, and O are all nonmetals, so they're covalently bonded, so we call it a molecule, not a formula unit. Okay, so that's a big long set of writing there. And we want to change it to moles. So 1 mole goes on top, and the number of molecules equal to 1 mole goes on bottom. Now up here it tells me that 1 mole is 6.02 times 10 to the 23rd molecules. So on bottom I'm going to put 6.02 times 10 to the 23rd molecules, and that would be H2SO4. Now, key here is that if you are dividing by something with scientific notation, is you have to put that in parentheses. So then your final answer, if you take 6.79 times 10 to the 24th times 1 and divide by 6.02 times 10 to the 23rd in parentheses, you're going to get 11.3 moles of H2SO4. Okay, put that where you can see it. And number 8, we are changing 8.90 times 10 to the 22nd atoms of calcium to grams. 8.90 times 10 to the 22nd atoms of calcium. We're changing it to grams. It's 40.1 grams of calcium in 6.02 times 10 to the 23rd atoms. Don't forget, put it in parentheses because it's scientific notation. Take the 8.90 times 10 to the 22nd times the 40.1, divide by the 6.02 times 10 to the 23rd in parentheses, and you get 5.93 grams of calcium. Okay, number 9. A couple of conversion problems for pressure. We had to do these in the gas law unit. We're changing 1.23 atmospheres to millimeters of mercury. And the millimeters of mercury conversion factor is up here. It's 1 atmosphere equals 760. So that means 760 goes on top. 1 atmosphere goes on bottom. Final answer, 935 millimeters of mercury. And lastly, number 10, 54.5 psi. We're going to change it to atmospheres. Let's see here, 54.5 psi. 1 atmosphere equals 14.7 psi. And 54.5 times 1, divide by 14.7. And our final answer, 3.71 atmospheres. Okay, keep checking back for more lessons to come. And we'll have lessons for Tuesday, Wednesday, Thursday, and Friday also. Make sure everybody is staying safe and not getting infected and not infecting anybody else. Just shelter in place and be safe and wash your hands. And we'll all come back together again once this has all been resolved. So take care, everybody. And this is Mr. Koker. Hopefully you'll be seeing Mr. Davis soon on one of these videos as well. So take care. Goodbye.